Hey YouTube, back at it again. Took a couple of days off, had a few issues that I had to deal with the family health and all that kind of stuff, but everybody's doing well for the moment, so I'm back out here in the garage. Thought I'd give you a little update what's going on. And be back on the lower A-pillar repair. I've been working filing and getting the edge fit up. Since I'd like to TIG weld this, I need a really nice tight fit. The closer this can be just to a solid line between the two metal, the better. This particular gap is not the worst thing in the world. I can get it to fill and bridge over that. It's about 3/16 of an inch or so. What I can do is take this copper backing bar, there's a piece of copper that I've got, and put it up on the back side so that it will absorb the heat as I'm welding that sheet metal and keep it from blowing through, making a big hole. It'll keep the weld nice and tidy and help keep this thing from warping up. You do the same thing with the TIG as you would with a MIG welder. You hit spot and then go to another spot and just kind of bounce around with your tacks to keep things from warping up. But it's fitting up pretty well. I already shot the time lapse for it, but I'll show that after this video here. But I'm probably going to take it on and off another 2 or 3 times just to really fine tune everything. You know, I could technically do it right here, but I want it to fit up as best as I possibly can, and it's worth it to take the time to do it as far as how it does in welding. This is a warm day again. It was cool for most of the week, and it's back warm, but at least it's kind of breezy, which is nice because it keeps me cool in here. So I got the back door open, window open, big shop door open, but that's a detriment for welding because I got to keep my welding gas around there and the wind blows it away. So once I start welding, I'll have to close up. I'll leave the front door open, but I got to close the windows and the back door just to keep the cross breeze from going by, because I'm not paying that much for welding gas to have it get blown away and still have poor welds. But one thing I did work on in between these videos, which I didn't show because I showed it in a previous video, was I just flipped the floor over. So now I'm looking at the bottom side of it, and I seam sealed the other side of those cuts in the floor for the tabs that I'm not using, didn't bend. I just wanted to seam seal both sides so I didn't have any issues whatsoever. And it was easier to do it here before I put the floor in than afterwards laying on my back, because I don't have a lift, and I didn't want to be doing that seam sealing while laying down. But it's not too bad to move around. My wife came out and gave me a hand flipping it over, but one person can do it on their own. It's really not too bad. I just didn't want to drop it. I had wanted sitting on these roller dollies when I first tried to flip it by myself, and they don't have locking casters. It's just the inexpensive ones from Harbor Freight, and they started to slide out of the way as I was lifting it up, and it was going towards the car. And I was like, oh no, come give me a hand. So she came and saved the day, which is cool. And she also gave me a hand doing some of the seam sealing, so a little bit of work with the car. So she doesn't help me out that much, because when we were working on a C10 a few years ago doing an engine swap, she was surprised at the amount of swear words coming out whenever I hadn't taken the radiator core support out, and we were trying to tip the engine and trans in, and it was getting kind of locked up. And I was like, I don't want to drop this on my leg. So it was just bleeps and bloops that you don't really want coming through on this channel. So I try and make sure this thing stays clean so families can watch it. So yeah, if you want to watch one of these videos with your kids or grandkids or whatever, you can, because I'll make sure to keep it clean. So. actually got an opportunity to demonstrate that copper bar there. I had forgotten about that I had a 1/8 inch drill bit hole right here on this flange that I needed to get welded up because of the geometry. It's difficult to get in from this side to weld onto that piece, so I did it from over here. But I didn't want to have to pull the trigger and let it cool and kind of build up a larger blob. A nice thing about using a copper, or you can use aluminum bar, like a piece of aluminum angle iron or just aluminum bar, and it'll absorb the heat initially of a little bit hotter wire weld without having the steel stick to it when it's molten. So that's why I put that back there, because I didn't want to blow an even bigger hole. It was a little rustier, and I used the MIG welder on that spot because it is a little dirtier, and I sprayed some of this weld through primer beforehand just to keep some spatter down on some of this stuff since I'd already got cleaned up. But to TIG weld to this side, I'm going to have to strip that off again because it's weld through for wire welds, which are a little more tolerant for contamination. But even though it's weld through primer, using the TIG welding process, it really wants to be like super highly clean, and you don't want to have that stuff on there. So anyway, I'll get the time lapse set back up here and keep getting after it. thought I'd stop for a minute and show you around the tacks that I've got going on. About every 1/2 of an inch is the spacing on these. Let's see. If they stick up a little bit proud, I kind of knock it down with a hammer and dolly, as you saw. Just trying to keep everything flush. As the weld puddle cools, it'll actually squeeze the metal in. So you want to hammer and dolly those and let it relax, relieve the internal stress in there. So that's what I was doing, is just hammering on the tack to relieve that stress, because the molten metal, as it cools, it constricts, contracts, and cools smaller than the liquid puddle, and it'll actually pinch things in. I don't know if you ever done it, but if you run a tack and just go tack, 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 tack in a line starting from one side on something that you're wanting to maintain a gap, you'll notice that as those welds, the tacks start shrinking, the right end here, say if I was going left to right, would be completely closed up, even if I started with a gap, if I had it on, you know, and those clamps all clamped up, because it's sucking together. So that's why you peen them, to relieve the internal stresses. And it actually sucked up just a little bit right here. I made this relief cut because the flange here didn't quite line up, but I didn't get that edge underneath and tacked before putting this tack in, and it pulled the end up, and now it won't go in there. So I'm going to have to go in. I'm not going in with the cutoff wheel, because this is actually way too thick. See, that gap is, compared to the crack size, is actually really big. The kerf that it would make, it's almost the size of this gap. So what I'm going to do is fire up the air compressor and use my body saw, because the blade kerf is a lot smaller, and then just get in there and make a small cut there that'll allow me to hammer that piece in and get this inner radius flush with the existing material, and this inner edge kind of smoothed out right there. It'll be covered and you won't really see it, but I want to know that it's smooth and as good as I can possibly get it. You know, metal finish everything as best as you can, and try not to hide it with Bondo and all. And you can see these holes, I use my little air punch thing to pop those holes in there pretty quickly and drill out, and then just sit in one spot and do a little rosette. Kind of mimics a little bit how the factory spot welds. You can see a couple of them right here. It's just kind of a divot. You can grind them flush or just leave them that way. I think I'm just going to leave them because I'm going to seam seal. You see how far the factory seam seal edge was on this thing. So I'll just seam seal over it and you won't see it. I will grind this down nice and smooth and body work it. But the nice part about the TIG welds is you see the size is very small. The width wise of it, but the penetration is really good. And then the metal itself, it actually cools softer than a wire feed welder. So if I was to use the wire welder on this, it would put a larger bead that's harder and just eat up my abrasives. It takes, you know, more time to sand it down smooth, puts more heat into the panel with your sanding. You know, as your sandpaper wears and you just press a little harder, it actually builds more heat. So it's better just to swap your sandpapers over when it loses its cutting edge rather than push harder. But with the TIG weld, what's nice is, you know, sometimes on these edges you don't even need to use like the dressing wheel or anything. You can actually just use a file to dress down the surface of the welds, because it's not as hard. It's just because it's cooler, it doesn't get as hard whenever it cools down, because it doesn't cool down from as high a temperature. So really good. But yeah, I'm gonna put this now on time lapse. I tried to have it in real time for you for that one. I apologize for the fan noise for the TIG welder, but it's unavoidable. Yeah, I'm gonna set it up on time lapse to finish up the actual welds on here, and then yeah, we'll get to dressing those down either tonight, or I might come back tomorrow or take a day off or something and then grind and dress it down. We'll see how it goes. But anyway, let's get to welding. Well, here's that finished TIG weld. You can see the smaller size of the weld bead. I'll try and hold it here on the edge. You can just see how flush it is. Look down this one. It's so small. And that weld metal is softer than a wire feed welder is, so it's going to be easy to grind. But yeah, and the heat control, you can see I welded around that hole for that door jamb switch for the dome light, and it didn't blow it out. These panels on this A-pillar is particularly sturdy. They're pretty thick, so they were able to take heat a lot better than like a fender or something. Like for this C10 door that I got behind me, that's a lot thinner metal than the 55 Chevy is. This is from an 85 C10, and so it's a little more forgiving on these older cars just with a thicker metal. But still, it's the way I like to go with it whenever I can, when the base metal is clean enough where I can actually do it. So I got a little bit of heat in here, but I didn't lay down a bead longer than about 1/4 of an inch, and usually a little smaller than that. Hopefully you're able to see that pretty well. But yep, it's just a good way to go. So I'll get this weld dressed down and cleaned up before I head in the house. So back to time lapse for that. Well, here's the almost finished product. Got a little bit of the weld edge here left to take care of, but what happened is this metal sunk in at this point, so I'm going to have to get in there with my hammer from the back side with the dolly on the front to push that back out before I can dress this down. You don't want to just sit there and dig it to make it hide, because your metal will get really thin at that point and it'll put a lot of heat in to do that. But this front side, in this spot about right here, it kind of bulged out, so I just hammer and dolly that back flush, and yeah, looks pretty good. Blends in real nice. I'm pretty happy with that. So this will take a little more time. I could probably spend an hour working just this section to get it just right, you know. But let's see here. There we go. The radius, that edge that I welded, that vertical cut that I made the pie cut for it, I got that blended in pretty nice. Got a little bit to do on the flange, but not that bad. And then just a little bit, let's get this darn thing where we want it. Yeah, see, it's got just a little bump right there on the edge of the flange right here. So I think I'll probably clamp that copper bar to the backside right on the edge, touch up that edge, that little dip right there with a little metal, and then just knock that smooth on the side. Try and make it where you can't even tell that anything's been done. But right now I'm pretty happy with it. I think it looks pretty good. So I know this video wound up being a little long. I appreciate everybody who stuck around to the end, and if you haven't already, like, share, and subscribe. Thank you very much.